back to our calculator, 1100 minus the answer, we give you $733.33. So 733.33 at 6%. So there's your two answers. How much should I invest at 12% and how much should I invest at 6% in order to get a return of 7% from our $1,650? Okay, example 5 says a pilot wants to make a 750-mile round trip from Scottsboro to New York and back in 4 hours flying time. So he's going to be in air for 4 total hours. There will be a headwind of 25 miles per hour going to New York and a tailwind of 45 miles per hour returning to Scottsboro. At what constant rate can the plane be flown? The formula, or what you need for this problem, distance is rate times time. That is one of the most common sense type equations. You might not know it, but you use it anyway. Distance is rate times time. Let me kind of make you a little bit more familiar with this. If you go 50 miles per hour, that's your rate, for 2 hours. How far did you travel? 100 miles. You use this formula whether you know it or not. That's it. Calculating time. If you're going to drive, I'm going to drive about 60 miles per hour. If I've got 240 miles to go, it's going to take me about 4 hours to get there. You use this formula. Let's use it in this context, though. Pilot wants to make 750-mile round trip. So it's obviously 375 there. So the way we're going to set this up, I always do it with a chart. You've got two different things happening with this. This is all my distance, rate, time problems I set up like this. You got to and from. The rate, which I'm going to put here, times the time is going to equal how far we actually travel. Thank you. They say that we're going to travel at a constant rate. To and from is a constant rate, but the problem is, I'll go back to the chart in a minute. The problem is the headwind and the tailwind. Headwind slows you down. You've got a wind blowing against the front of the plane. It's going to slow you down 25 miles per hour. Tailwind is going to speed you up 45 because you got a tailwind blowing from behind you. So we're going to let x be our constant rate. Let x equal speed. But let's see, going to New York says there's a headwind of 25 miles per hour, so instead of actually traveling at x miles per hour, it makes sense that we're traveling at x minus 25 miles per hour. Got a headwind, instead of traveling at a constant speed, it's slowing us down. Got a tailwind coming back, so instead of traveling at x, you're traveling at x plus 45. $750-mile round trip. 750-mile round trip. Let's fill in what else we know. That means 375 there and back. This problem's worked a little bit different from because normally they give you a rate and a time, and you're asked to find the distance. They do give you a time. You only want to travel for 4 hours. But the problem is, since you're going actually slower to than you are back, you don't know what percentage is which. And I don't even know if we need that information. The actual about the time, about we want to do 4 hours down there, 4 hours back. I'm not sure. So therefore, if distance equals rate times time, we're actually given a distance and a rate, and to actually find our time, okay, I got you now. And in order to find our time, we're going to have to take our distance. Let's kind of manipulate this formula a little bit. If you go, I kind of said this a while ago, if you've got to travel 120 miles, and you're going to travel at 60 miles per hour, how long is it going to take you to get there? 2. How'd you find that? You did distance divided by rate is equal to time. So this time is going to be distance divided by rate. This time will be distance divided by rate, and this is where the 4 does come into play. It makes more sense to me now. I was kind of lost there for a second. This is the time it's going to take you to get there. this is the time it's going to take to get back. We want that total time to add up to equal how many hours? 375 over x minus 25 plus 375 over x plus 45 equals 4. There's the equation we're going to have to solve. So what we're going to do to actually solve this is we're going to type it in 375 over this plus 375 over this. We're moving our 4 over minus 4. We're going to graph it and look for our x-intercepts. So when I hit graph, and it still has a scale from a while ago, so I'm probably going to have to change this because you don't see anything. Again, since x is a speed, we're not going to have to put negatives here, but I am going to have to change my window. Let's try from 0 to 100 miles per hour. See if we get anything on the graph there. Yeah. That's actually going to be an asymptote line. That's still not part of our graph because you see how it came straight down. Talk about asymptotes again later on. Let's try up to 200 miles per hour and let our scale be 25. There you go. I think you have an intersection there. And that's what you need. You need to know what your x is. You can move it further to the right just to see if you're going to have more than one solution. I don't think you're going to. Let's do it just to be safe. 300 miles per hour. I don't think it's going to be going faster than 300. Yeah, it looks like it's going to be our only solution. If you'll keep in mind what x represents, what y represents, then it's going to help you out. So we're going to do, let's see, I let each tick mark count 25, right? So that's 25, 50, 75, 100, 25, 50. Looks like 175. I'm going to say between 150 and 200 is where our answer is going to be. So 0, left bound 150, right bound 200. Guess somewhere in between. 183.8. So x equals 183.8 miles per hour. If you know how to graph, or if you know how to solve equations using this method, that was much easier than the way we solved it last year. Graph it, see what your x-intercept is. In this case, the speed that we're going to have to go in order to travel this distance in 4 hours, 183.8, which you could subtract 25 and add 45 to see how fast the plane was actually going. But 183.8 is what he's going to have to set his cruise control on. Here you go. Example 6. It says a landscaper wants to put a cement walk of uniform width around a rectangular garden that measures 30 by 45 feet. So we've got a garden. Again, here goes my pictures. That's 30 by 45 feet. And we want to put a walkway around it. Of uniform width, that's important. Which of course mine doesn't look like it's uniform width. But what that means is the width all the way around this garden is going to be the same width. We're going to let that width be our unknown. X. The distance from here to here is x. The distance from here to here is x. That's very important. She has enough cement to cover 750 square feet. How wide should the walkway be? She has enough cement to cover 750 square feet. You see you have a big rectangle. You have a rectangle inside a rectangle. Are you going to cement the entire thing? No. That's it. That's going to be your strategy. You're going to take, because we're only going to cement this part. Just the walkway. You don't really want to cement your flower garden inside here. So what you're going to do, you've got to figure out, okay, what's the width of the big one? What's the length or height of the big one? And then minus the area of this on the inside, and that would give you just the area of the walkway. So how wide? Think about this. This is x. This is x, because it's uniform width. This is how wide? 45. So how wide's the big rectangle going to be? 45 plus 2x. You have a 45 in the middle, an x on the right side, and x on the left side. So 45 plus the 2x's. How tall is it going to be? 30 plus 2x. This problem's a little bit easier than the last one. And you want to use 750. So what we're going to do, we're going to take the area of the whole thing, which will be length times width. That's the area of the entire, including garden and everything. is 30 plus 2x times 45 plus 2x. But you don't want to submit the whole thing. You want to subtract off the middle, which will be what? How do you find the area of the middle? Yeah, 30 times 45, which is 1350. And we want it to equal how many square feet? Because, again, this is what we're going to submit. We're going to submit the whole thing minus the flower garden, which just leaves us with the walkway. And this one's easy. If you want to, type it in like it is. This is going to be quadratic, though. I'm going to solve it using the calculator just because I can type it in. Move my 750 over. Then I'm going to have 30 plus 2x, 45 plus 2x, minus 2100 equals 0. So what I can do now is type in the left side, look for my intercepts. So here we go. I've typed in the equation. And again, all we're going to do now is graph it, look for your intercepts. 30 plus 2x, 45 plus 2x minus the 2100, graph. And I'm probably going to have to change my scale again because, well, the entire graph is right here, because now you're talking about the width of we went from talking about the speed of an airplane to it went up to like 300. Now we're talking about the width of a sidewalk, which is going to be like 1 or 2 feet. So we're going to have to change our window. Instead of from 0 to 300, let's do 0 to 5. Oops. 0 to 5 with a scale of 1. Graph. So it looks like we're going to be somewhere between 4 and 5 feet. It's going to be the width of our walkway. Let's do second calc. Find our 0. We know it's between 4, enter, 5, enter, enter. 4.47 feet. So about 4.5 feet. You've got to be careful there. That's a good thought. Should you do 4.5 feet, 4.5? No, because you're going to run out of cement before. To be safe, I didn't even think about that. To be safe, you'd either want to do 4 feet, or if you feel really confident about your measures, 4.4. You could get by with 4.4, and you would have just a little bit of cement left over. Okay, example 7. Example 7 says a box with no top has a volume of 1500. Is to be constructed with a 25 by 35 inch sheet of cardboard by cutting squares of equal size from each corner and folding up the flaps. This is a very common algebra problem. You've got a sheet of cardboard. You're going to cut squares out of the corners. Do you notice when you cut these squares out of the corner, you could fold up the tabs and you've got a box? Does that make sense? You're going to cut the same size squares out of each corner, x by x squares. The original piece of cardboard is 25 by 35, so it's 25 tall, 35 wide, the way I drew it. We want a box with a volume of 1500. This goes back to how to find volume again. This is very similar to the problem a while ago. This was not a hard problem. Once you actually picture how the box is going to be constructed. Imagine folding along this line, folding along this line. How tall is your box? How tall is it? When I say tall, this. You see that this is the height? When you fold that tab up, the height is x. Let me draw my dotted lines here and here also. The height of your box is going to be x, because no matter all the different tabs are folding up, the height is always x. The width, the distance from here to here, is the same thing as the distance from here to here, because you're folding up the rest of that. So the whole thing is 35. The distance from outside to outside is 35, but this part and this part is not included with your width. So the width of your box is now 35 minus, can you finish that? Close, 2x's. Minus the x over here, minus the x over here. So you have a width of 35 minus 2x. Same thing, we're going to do the same kind of thing here. The whole distance here is 25. You've got to take out an x here and an x here, so that would be 25 minus 2x is the dimensions of your box. So we have x, 35 minus 2x, and 25 minus 2x. How do you find the volume of a box? You multiply length times width times height, so we've got to do x times 35 minus 2x times 25 minus 2x, and we want our volume to equal 1500. Again, we simply type all this into the calculator. Look for the x-intercept. Well, we're going to move our 1500 over as well. Look for the x-intercept. There's going to be your answer. So we've taken and y equals, and we put in the equation. Do the same thing, graph. We're looking for the x-intercepts. We see that we've got an intercept between, I've got the same, I can zoom out, but I think this is going to be my only solution. I could do window and change it from 0 to 20 just to be safe, but I think that's going to be my only solution there. Well, no, you're right, have 2. Have a solution looks like between 2 and 3, and we're going to have another solution between 4, 5, 6, 7, and 8. Let's do it the same way we've done the other problem. Second calc, looking for our 0. First one's going to be between 2 and 3. 2.5 is our first solution. Our second solution was between, what I say, between 7 and 8. Second calc, we can do between 6 and 10. It'll still find it. 6, enter, 10, enter, guess. Second solution, 7.5. Both of them will work. So it says, the actual problem says what size should be cut from each corner in order to obtain this. You can cut a 2.5 by 2.5 inch square out of the corner, or you can cut a 7.5 by 7 inch square out of the corner. And you'll still have, either way, it's the same as a while ago. We wanted a volume of 1500. If you cut a 2.5, it's going to be kind of like a gift wrap, like a present box, to where you're going to have a volume of 1500. If you cut 7.5, it's going to be like a tall, skinny box. Example number 8, final example. It says a radiator contains 10 quarts of fluid, 30% of which is antifreeze. How much fluid should be drained and replaced with pure antifreeze so that the new mixture is 60% antifreeze? This sounds really, really hard. It's not. It's one of the easier ones. It kind of goes back and it's worked the same way as the whole percent problem before. You have a radiator. This is where we're starting. We're taking fluid out. We're subtracting it off. We're adding the same amount of fluid back, and we're getting some new mixture here. So anytime I'm doing percent problems, I use boxes. So it says a radiator contains 10 quarts of fluid, so you're starting with 10 quarts, 30% of which is antifreeze. How much of that is antifreeze? 30% of the 10 quarts, that would be 0.3 times 10. That's 3 quarts. 30% of 10 will be 3. So 10 quarts, 30% antifreeze, which means 3 quarts of that is antifreeze. Everybody see how I got that? We're going to take out. It says how much fluid should be drained. That's your X. How much fluid am I going to take out? What about this, though? We need a percent there. Let's go back and read the whole thing. Radiator has 10 quarts of fluid, 30% is antifreeze. How much fluid should be drained and replaced with pure antifreeze? So we're going to drain it, then we're going to replace it. What percentage of this is antifreeze? 30, because it's what you started with. Does that make sense? You're going to add something that's pure antifreeze. What percent of it is antifreeze? Pure. 100% antifreeze. How much are you going to put back in? What you think about it? X. If you take out X, in order to get it back to where it was, you're going to have to put back in X. Makes sense? We want to end up with something that's 60% antifreeze. There we go. There's your 60. How much is going to be finally in your radiator after you take it out, replace it, and all this stuff? 10. Started with 10, took out x, put back in x, so you're back at 10. Yeah, the x's minus x and plus x cancel each other out. So we started with 3 quarts. We want to end up 60% of 10 quarts. We want to end up, if you do 60% of 10, you get 6. So pretty much what we're trying to do is double the amount of antifreeze we have in our vehicle. And I like this because you can see the application here. You started with 3 quarts, you want 6 quarts. How much should you take out and then put back in? Now you're going to see this is very closely related to the problem we did a while ago. 30% of this is antifreeze. How do you write 30% of that? 0.3x. 100% of this is antifreeze. How do you write that? 1x. So we're going to start with 3. We're going to take out 0.3x. We're going to put back in x, and it's going to equal 6 quarts. All I did was brought down my signs there. And then you just solve it. You see now why I said this is one of the easier problems? Because that's very linear. There you go. 3 plus 0.7x, because minus 0.3 plus 1 is 0.7, equals 6. And then calculator, because you did, hang on. Yeah, you did, this is 1x. 1x minus 0.3x would be 0.7x. So you got 3 divided by 0.7. 3 divided by 0.7. 4.29. So you want to drain 4.29, add 4.29 back, and you're going to get 10 quarts. That is 60% antifreeze.